Hello everyone. So in this video we'll see about operating system services and system calls. So whenever user wants to execute a program, then operating system provides an interface to collect that information, and it provides the services so that our user can execute its programs. So in operating system, under operating system, you have services provided. To call the services, there should be a system call, and this system call is initiated by user interface. So in user interface, it can be through graphical user interface like Windows operating system. Batch commands means instructions is given with batch wise, and command line interpreter like our Unix operating system. Whatever the mode the user interface is, it generates a system call which invokes the services of operating system. Services provided by operating system are program execution for execution of user process, input output operations, file systems, communications like resource allocations, and so on. Accounting is a service which is provided by operating system to maintain the services, like to maintain and account all the services which are happening under operating system. Error detection is also a system function to detect any errors which is executed in user program or not. Protection and security is also system service which ensures there is enough protection and security provided to the system, and all this is run on a system hardware. Next one is system call. So whenever a user is to execute, then there should be a system call or some function call to invoke system function. So this system call is like a function call. Function call invokes a function like general function. System call is also like the invoking a function, but it invokes system function or operating systems function. Programming interface to service provided by operating system. It acts as interface between your operating system and programmer or to the user, and typically like system calls are written in C or C++, like higher level languages. And instead of giving, like there is no need to give system call, or you don't need to call the function every time, system function every time. Instead, user is provided with high level application process or application programming interface like graphical user interface. If you want to open a file, just click on a file. Click on a file is an application programming interface which creates an system call like open. Open is a system call to open a file. Like that, application programming interface is enough to access that system call. And most commonly used application programming interfaces are Win32 API for Windows operating system, POSIX API for POSIX based operating system, and Java APIs for Java virtual machine. So here is an example of system call, like what and all the system calls called under one execution, like copying data from source file to destination file. So here example system call sequence for copying data from source to destination. Acquire input file name. First system call is acquiring input file name, then write prompt to the screen, accept input, acquire output file name. This is our output file name. Writing prompt, like you have to write this on the screen, accept input, then open input file. If file does not exist, abort, create output file. If file does not exist, then create output file. If file exists, then abort it. Means there is a file existing, no need to create it. Then loop, read input from the file, read the input from source file, write the output to the destination file or output file until read fails. Close output file, means close this destination file. Write completion message to the screen, terminate normally. So if you just give copy from source file to destination file, this is the system call sequence that has happening background. Next one is API, application programming interface First, system calls on operating system relationship. See here, you have system call interface and user application. User application creates an API as a system call, and there is a system call interface which is connecting between user mode and kernel mode. This API is converted to system call in system call interface, come to the main memory of that system, go to the address I where your open functions, like open system calls, system function is written, execute it, go back to the system call interface. This is what happens in background if an API for open function is generated. Next one is system call parameter passing. Like if you consider this, how this open function is created, here we have deeper view, how the data is copied, like how the system call parameters is copied and executed. Means parameter is passed from user program to operating system. In the user program, x is a parameter that is calling, like x is a parameter for call, loads the address of x and system call is 13. So x address to load, like you have to load the address of x which is calling the parameter. X may be the address and that address is copied to register, from register, like that address is present in register and that will go to the operating system. System call 13 is used for execution of parameter call x. So that system call, like one more pointer will go directly to the operating system at 13th system call. Use parameter from the table x. Code for system call 13 is available in this main memory block. With the help of x and the code of system call 13, user application is executed. Next one is types of system calls. Based on types of events, types of activities user has to create, like user is executing, based on that system calls is also segregated. First one is file management. For file management, we have different system calls for maintenance of file, like creating a file, deleting a file, open, close of a file, read, write, repositioning. Get and set file attributes is a service provided, like service operators which system service functions uses. Next one is device management, like requesting for device, releasing the device, read, write, repositioning, getting and setting device attributes, all those stuff. Next one is information maintenance. It's like all system functions like get and set date and time, system date and time, and file device drivers attribute functions. Next one is communication. For this communication, we have creating and deleting communication links, send and receiving message system calls, sharing memory models, all those stuff. Next one is protection. So for protection, we have control access, like read, write permission system calls, get and set permission. If a user is, like if a owner want to give permission, he can give the permissions for the file, and allow and deny the user access. Owner can allow and deny the user access. So all these are the system calls provided for protection. So here is the example of Windows and Unix systems based on types of system calls. These are the few system calls that are actually existing in Windows operating system and Unix operating system. For process control, in Windows we use create process to create a new process, and in Unix we use fork. And in Windows for exit, like to abort or to cancel the process, we use exit process. In Unix we use exit, and here in Windows we use wait for a single object. For waiting for the, if our process need to wait for input output transmission, we use wait for single object. In Unix we use wait. Like that, for file manipulation we have create file, but in Unix open, and so on. Next one is example of MS-DOS. So in MS-DOS operating system, this is how your main memory look before starting, like before a system is started up for the user process, and this is when user process is running. First, a part is reserved for kernel and command interpreter, then free memory. Once a user process start executed in the free memory, data is allocated for user process in kernel, like in the free space, and remaining will be segregated as free space. and if the process data increases, free space will be utilized, and if the process execution is done, then the process will leave the main memory and this data block is freed for the user, freed for free memory access. Next one is FreeBSD. Here MS-DOS is a single processing unit. We can execute only one process at a time, so only one process will be running in the main memory. So FreeBSD is a multitasking system, and this is Unix variant system where kernel, in the main memory, kernel space is allocated and different process will have blocks of data simultaneously stored in main memory, and the remaining space is allocated as free memory for next process or next execution of task. And if the process, in the multitasking, if any process execution is completed, that memory block is added to free memory again. So user login will invoke the user choice of a shell. For every user, a shell, private shell, different shell is allocated, and fork is a system call used to create a process, and exe is a system call used to execute. When the process exits, if a process completes its execution, then the process will return 0 if there is no error generated in the execution of process. If the value is greater than 0, then error, it means there is some error in execution of data. So I hope you all understood the system call functions. Thank you.